Hey, this is Horner, and this is Projectile Problems number 5, 6, 7, and 8. At her wedding, Jennifer lines up all the single females in a straight line. She's going to toss her bridal bouquet, and somebody wants to catch it. So notice each one of these ladies is at a different distance, and Jennifer turns around and tosses the bouquet behind her. When she does that, she throws it in this direction. So here we go. And it has a speed of 3.9 meters per second. Notice that it is at an angle, and that angle is 50 degrees. It's caught at the same height, so it's going to go up and come back down, and the time it takes for the total travel is equal to 0.6 seconds. They want to know who catches it. So we're looking for, where is this going to land? That's our delta x. Things that we need to find for delta x. Well, we know that Vx is equal to, Vxo is equal to the change in position over the time. We have the time. Do we have the speed? Almost. Do we look for delta x? Yes. So delta x, sorry, that's kind of weird, is equal to Vxo or Vox times t. And we have a triangle. So here's our triangle. This is 3.9 meters per second. We have our angle of 50 degrees here. And we have the other side of our triangle. So we want to find out what is the speed in the x. If we know the speed in the x, we can multiply that times time, and that'll tell us how far away she throws that bouquet. If I want to know this side, I see that this is the adjacent side. And so remember SOHCAHTOA. We're going to use cosine. And so we always do the hypotenuse, which is 3.9, times the cosine of the angle, which is 50 degrees. And that will give me my velocity in the x. So remember, this is actually the velocity in the x. 3.9 times the cosine of 50 gives me 2.51, so Vx is equal to 2.51 meters per second. And at this point, I can say, yay, I want to know how far it goes, so I'm going to plug in the Vxo, which is 2.51. I got that over here. My time is 0.6, and if I multiply those two together, I get 1.5 meters. And so Kendra is the winner. If she had thrown it slowly, so if this speed instead was lower, then who would catch it? And that would have to be Kelly. And Kelly catches it because less speed in the x direction means less change in position. So it's going to be smaller. For the next question, this is number 6, at a modeling meeting, at a meeting of physics teachers in Montana, they want to know to calculate where a flour sack would land if it is dropped from an airplane. So we've kind of done one like this before. So here's our airplane again. Put our little thing on here. We know that it's moving in this direction, so this is our Vx. We know that when it's dropped, it's going to make our parabola, so it's going to look like this. And it says that the plane is moving at 60 meters per second. So last time we had to find the speed of the car. This time we are just finding out the horizontal distance that it travels here. So we're going to look for delta x. They told us that this plane has a speed in the x direction of 60 meters per second. And they also tell us the plane is flying at a height of 300 meters. So that's our delta y. We've got delta y's, we're trying to figure out delta x, so we know that anytime we go from a y thing to an x thing, we've got to find time. Remember, whenever you want to find time on one of these, we know delta y is equal to the original speed in the y times time plus 1/2 of gravity times time squared. Why is gravity positive? Because remember, it is moving down, and so we say down is positive here. The height is 300 meters. Voy times t is 0. Why? Because remember, in the down direction, it doesn't have any y speed. Okay? So when it is just let go, the bag of flour does not have any speed here yet. So that's equal to 0. Then we're going to do 1/2 of gravity and times squared. So here this is going to be 600 divided by 10. That gives us 60. And so we're going to do the square root of 60 is equal to time. And so our time is equal to 7.75 seconds to fall. So it takes quite a bit of time to fall. Let's figure out now how far it goes. So Vx is equal to the change in position over the change in time. We want to find delta x. So delta x is equal to Vx times our time. We know Vx, we were told it was 60. Our time is 7.75. So it travels a whopping 465 meters. They wanted us to draw a sketch of the flour sack. We did that already. Boink, boink. And so you're done with that part. For number 7, Jack be nimble, Jack be quick. Jack, you need to jump over that candlestick with a velocity of 5 meters per second. So here is our original velocity. Remember, it's not in the x or the y, it's in both. And this is 5. And then on the bottom here is the ground, and this is 30 degrees. They want to know if there is a candle here. So we're going to draw a candle. So it's got the little flame here. And that candle is 0.25 meters high. So 0.25 meters up to the top of the flame. Did Jack burn his feet? So this is our height. I'm going to put h because it's really not our delta y. We want to find out what is our delta y. And the reason we need the delta y is because if our delta y is bigger than 0.25, we know that he did not burn his feet. If it's less, we know he did burn his feet. Let's go through and find out what the velocity is in the y direction. So to do that, we got to remember so, ka, toa. And so let's go ahead and draw. So we've got our 5 here. We know that the angle is 30 degrees. And we want to find out what is Vy. What is this equal to? So it's on the opposite side, so we're going to use sine. So remember, and the reason we put the 5 first is because remember sine is equal to opposite over hypotenuse. So if I want to know what the opposite side is, I just take hypotenuse times the sine of the angle. So that's why we're doing what we're doing. This is 5, let's say Vy is equal to 5 times the sine of 30 degrees. And so we're going to end up with a speed here of 2.5 meters per second, and that is straight up. So that's great. We know that the original speed in the y, is equal to positive 2.5 meters per second. So let's think about an equation that would help us find the change in height. So that equation is actually the third kinematic equation. The final speed in the y is equal to the original speed in the y plus 2 times gravity times the change in height. So that's delta y. Here's the interesting thing. I know that the final speed in the y, okay, the final speed in the y, if I'm going all the way up to the top, remember your speed at the top, your velocity final in the y is going to be equal to 0. So this is 0. And that's equal to our original speed in the y. It's up, it's 2.5. And then we're going to add to that 2. But now our gravity, since up is positive, down is negative. So gravity is negative in this case. So this would be negative 10. And this would be delta y. We're going to subtract 2.5 from both sides. That's negative 2.5 is equal to negative 20 times delta y. The negatives will become positive because you got them on both sides. If you take, this is 2.5, and I forgot the squares. So easy to forget. So we're going to put 2.5 squared, and that is 6.25 is equal to 20 times delta y. So our change in height there is 0.31 meters. And so no, he does not burn his feet. And that is because 0.31 meters is greater than the height of the candle flame, which was 0.25 meters. Last question. Esther dives off a 3-meter springboard and initially bounces up with a velocity of 8 at an angle of 80 degrees. So she is going this direction, 8 meters per second. That is our original velocity. And we know that the angle here is a whopping 80 degrees. So really it's going to look more like this. Okay, but we're going to just leave it the way it is because we're not too worried about what it looks like. We're looking for some other things. All they want us to do here is just find the horizontal and vertical components of her velocity. So we're just looking for Vx and Vy. So this should be super easy. Vy, remember, is the opposite side. So this is going to be 8 times the sine of 80. And Vx is equal to 8 times the cosine of 80 because it's the adjacent side. And so for x, I'm going to get 1.39 meters per second. And for y, I'm going to get 7.88 meters per second. And think about it, does it make sense? If she's going up at an angle like this is 80 degrees, she has more velocity in the y than she does in the x. And so that makes a ton more sense. And that is the end of the second video, number 5 through number 8.